In 4.2 extra practice, taking a look at question 2, we are still continuing to use our knowledge of scale factor as being represented using equivalent fractions. So a reminder that when we're working with given equivalent fractions like this, we want to check that we are first identifying the fraction that we have both pieces of, so in terms of numerator and denominator. So if I jump in on question 2A here, I see that we've got 1/8 as equal to some unknown number out of 624. So starting with finding the fraction that we have all of, so in this case I can see we have the complete fraction on the left, 1/8, which tells us that we're going from the completed fraction towards the incomplete fraction. From here, we want to start with either the numerator or the denominator, but we want to start with whichever we have both pieces of. So in this case, I have both denominators. So again, going from the completed fraction on the left, headed to the fraction on the right, we want to think to ourselves, 8 times some unknown factor will give us an answer of 624. Depending on where we're at, some of us might recognize this value a little bit more quickly, but I would recognize that for most of us, we're probably going to want to head the opposite way rather than doing a lot of guess and check, and recognize that 624 divided by that known 8 will give us that unknown value. In this case, that value is 78. So 8 times 78 gives us the value of 624. Lastly, because we can recognize that we want to maintain that equivalency, that equal sign in the middle, the bottom was multiplied by a factor of 78, so we're going to do that same change on the top and multiply our numerator by 78. One group of 78 gives us 78 out of 624. Lastly, I would encourage that step of double checking our work, where we can either use the opposite direction, so I could say 78 divided by 8 equals 1, 624 divided by 78 gives me 8, or I could also convert both into fractions by simply taking numerator divided by denominator equals a decimal. Here I can see that I get 0.125, and when I also do the same on the left-hand side, I also get a decimal of 0.125. So again, just taking the time to double check that our answers are reasonable. Let's take a look here at question, let's do part D. So I'm just gonna take some room here and copy it down. I've got 1 over an unknown denominator in this case is equal to, on the right-hand side, I've got 15.3, and on the denominator, I have 1,224. Again, start by checking to see which fraction do you have complete. In this case, we've got the fraction on the right is complete, 15.3 out of 1,224, and the incomplete fraction is on the left. That tells us that we're going to be heading from the right to the left in this case. And now pausing to look at either your numerator or denominator, because we have both numerators, we're thinking to ourselves, 15.3 divided by what equals 1? Any number divided by itself will always equal 1. That should be a value or an idea that is pretty automatic at this point. And again, we want to continue to work on building fluency as well as competency. Lastly, we've got our denominator of 1,224. We're going to divide by the same value of the 15.3. We need to divide top and bottom by the same value in order for the two fractions that we express to be equivalent. And I have a new denominator of 80. From here, again, pausing to just check that your answer is reasonable. I'm going to do that by checking my two fractions independently and converting them into decimals. On the left, I've got 1 divided by 80 equals 0.0125, and I'm going to check and just take the time, the 10 seconds required to check, on the right-hand side that my 15.3 when divided by 1,224, that I do in fact equal 0.0125. And because I have both decimal values, I can see there, I can prove, or I can rationalize that those two fractions are equivalent values.